Okay, so today we're going to talk about theorems about the roots of polynomial equations. And we did learn yesterday that we can find roots of polynomial equations, and the easiest way, I'm sure we can all agree, was that synthetic division. And we were looking for a remainder of 0, which would tell us that we had found a root. And yesterday, we were stuck with this belief that we would literally have to try any number in the universe to see if it was a root. And what we're going to talk about today is the rational root theorem. And what this is going to give us is a smaller set of possibilities. All right? So let's go through. The theorem is quite technical, but the concept is actually not difficult. So I want you to see that in a polynomial, your very first coefficient is a sub n. That's that lower n, sub n. And your constant at the end is a sub 0. Okay, a sub 0. Now, your possible roots in this polynomial function have a reduced form of P over Q, where P is a factor of that constant. That's this guy right here. And Q is an integer factor of your leading coefficient. All right, so what we can do is it's really easy to find out all the possibilities for P and all the possibilities for Q. And once we do that, we've got our possibilities. And then we're just stuck with figuring out which ones work. All right? So let's go down here to the example we've got. It says, what are the rational roots of this expression? So, P has to be a factor of 5. Which, would you agree, is plus or minus 1 and plus or minus 5. It's always plus or minus because it could be either one. And Q is a factor of our leading coefficient, 2. So that's plus or minus 1 and plus or minus 2. Okay? So all the combinations of P on top, Q on the bottom would give us, take 1 over 1, that would give us plus or minus 1. Take 1 over 2, that would give us plus or minus 1/2. Take 5 over 1, that gives us plus or minus 5, and then 5 over 2, which gives us plus or minus 5 over 2. So do you see how that's 8 options? That's it. That's all there are. So instead of the whole possible universe out there, we have 8. If this has rational roots, these are the only possible things it could be. That's it. All right? So at this point, we have to figure out which ones they are. Of course. Yes, ma'am. They are not. Okay. Sure. Bye. Okay, that'll be a little editing expedition later. Okay. Let me do this. edit. Okay. Now when I speed through that, I'll look for that. Okay, so now here's the issue. We have to try all these. Now, I'm going to tell you, we could sit here and we could do synthetic division and try all these, but it's going to take us a while. All right? I just want to show you how you can try all these, and maybe some will be roots. At most, would you agree, there's just going to be 3. X to the third gives us 3 roots. So the most there's going to be is 3. There could be as few as 0. All the roots could end up being imaginary or something else, but we'll see. So here's what I'm going to do. I'm going to make a little table, and we're going to use our calculator on this expedition to help us get through this. So let's make a little table, and I'm going to put 1, -1, 5, -5, 1/2, -1/2, 5/2, and -5/2. And what I want to find is P of X. And all I want to do is, if it is 0, then it's a root. So let's put that right here. If this is 0, then that P over Q is a root. To find P of X, use synthetic division. But I'm going to go faster for the purpose of notes. And I will tell you, when you do this on problem 9 through 17 is where you have to do this. I want you to use the synthetic division process to do this, okay? And I'll do on the next page one with the synthetic division process. But I'll show you also on your calculator so you know how this would work. So I'm going to go to y equals, and I'm going to put in this function. So my function here that I'm putting in is 2x raised to the third power minus x squared plus 2x plus 5. And I'm going to enter that. Okay. Now, what I'm going to want to do is I'm actually going to want to use the table feature, and that's this right here. But we got to go to table set because I need to show you something. When you are doing this, you want to go to ask. All right, because you want to put specific things in there. All right. So we want it to say ask, but mine already does. So I'm going to go here and I'm going to put in a 1. And what it's telling me is that my y value, which goes with this, which is my P of X value, is 8. Okay? Now I'm going to put in a -1. That's my next one. Oh, I got a 0. Do you know what that means? That's a root. All right? -1 is a root. Now, I'm going to put 5 in, and I get 240. I'm going to put -5 in, and I get -280. 1/2, I don't know if it'll let you, whoops, put it in as a fraction. Yep, and I get 6. -1/2 is 3.5. 5 divided by 2 is 35, and -5 divided by 2 is -37.5. None of this is important with the exception of this piece of information. This piece of information tells us that -1 is a root, and what this means is that x plus 1 is then a factor, right? Because it's x minus whatever the root is. So remember, it came from this. X equals negative 1, add 1 to both sides. X plus 1 is the root. All right, so x plus 1 is a factor. Now, you would have to do long division or synthetic division to find out what you have left after you factor that out. And I'm telling you, what will happen is your remaining roots are either irrational, which means they have square roots in them, or they're imaginary, and you would find them using the quadratic formula that you had left after you factor this out using synthetic division. I'm going to do that on a problem on the next page. So let's go ahead and turn the page. Whoops, let's get that right about there. Okay, what are the rational roots of this? So remember, P is a factor of 2. So this gives us plus or minus 1, plus or minus 2. And Q is a factor of 15. Oh, this is a lot of options. Plus or minus 1, plus or minus 3, plus or minus 5, and plus or minus 15. Okay? Those are our possibilities. We want to see how far we can factor this out, okay? So we are looking, first of all, to figure out P over Q. And P over Q could be plus or minus 1, plus or minus 1/3, plus or minus 1/5, plus or minus 1/15, plus or minus 2, plus or minus 2/3, plus or minus 2/5, and plus or minus 2/15. Okay? A lot of options. You know what I always say? By golly, try the easy ones first. All right? So here's what we're going to do. I'm going to put this in, and I'm going to try a couple. So I'm going to put x equals my P over my Q. I'm going to start finding some of these. So I want to start with 1, -1, and 2, and -2. And then I can make more and do more. All right? So get my calculator out, and I'm going to put my function in. So go to my y equals, clear that out, and I'm going to go and put in 15 x to the third minus 32 x squared plus 3x plus 2 and enter. So let's go over to the table, and I'm going to put things in here. I'm going to try 1, and with 1 I get -12. With -1, I put 1 in here, that's a -48. So far we haven't found anything. 2, oh yay, we found 1! That's a root. And I'm just going to try -2 because it's so easy. Nope, not -2. Now, all I want to find is 1. I do not want to go about putting all those fractions in because I found 1 and I'm happy with that. So here's what I'm going to do. 2 is a root, right? Okay, synthetic division it. So put a 2 here. Put your function, which is 15, -32, 3, and 2, right? And we're going to synthetic division this, and we're going to end with a 0. We know we're going to, because we already said we were going to, because it's a root. Bring your 15 down. 2 times 15 is 30. You put that here, add, and you have negative 2. Multiply. Put the negative 4 here, add. That gives you negative 1. Multiply gives you negative 2. Add those together and you get 0, which is what we expected. But there's a reason why we did that. And that is because what is left is 15x squared minus 2x minus 1. All right? Now, would you agree with our box method and slide and divide and grouping method, it's probably faster to do that than to put all these freaking fractions in, right? Yeah. So our other factor, which we already figured out, was x minus 2. All right, so now we'll put a little arrow here. Use the box method. Okay, so a refresher of the box method. We're going to put our 15x squared here, negative 1 here. We need it to multiply to negative 15x squared, and we need it to add to negative 2x. What could it be?
3 and 5.
I like that. How about negative 5x and positive 3x? That give us the signs we need. Greatest common factor, 5x, which makes this over here a 3x, makes this one down here a minus 1, and this one just a 1. So we know that this factors to 5x plus 1, 3x minus 1, and then we have that x minus 2, right? So let's just go over here, and we know based on this, our roots are, would you agree, this one is going to give us negative 1/5. Right? Set it equal to 0, subtract 1, divide by 5. Yeah. Set equal to 0, add 1, divide by 3, 1/3. And this one gives us 2. So look at, we got all of our roots. But we didn't have to do all of these fractions. Just get one, and it gets you to an easier place. Yes?
So, if, like, we don't have all the fractions, we don't have to do the box number. Like, if we just have a couple, like, numbers, we can just do the chart, like the table, and then be done with that?
No, I want you to learn to do this.
Oh, okay.
Because here's the issue. There are going to be times when you're going to do them all, and you're not going to find them, because they are not rational. And what you need is this trinomial then, so you can use the quadratic formula on it. So just find one, synthetic division it out, and use what you know how to do to go to the next step. Because you may not have all rational roots. All right? So that's pretty cool. Okay. This is kind of neat. The conjugate root theorem, and here's what this says. If you have a polynomial and the coefficients are rational, then irrational roots of the polynomial that have the form a plus the square root of b occur in conjugate pairs, which means that if a plus the square root of b is an irrational root, then a minus the square root of b is also an irrational root. Same thing works with imaginary roots. So, if p of x is a polynomial with real coefficients, then the complex roots of the polynomial occur in conjugate pairs. That is, if a plus bi is a complex root, then a minus bi is also a root. So let's go down here to example 3. I have a quartic polynomial p of x, and it has rational coefficients. If the square root of 2 and 1 plus I are roots of this polynomial, what are the other two roots? This is really simple. Negative square root of 2. Okay? Because a plus the square root of b, a minus the square root of b. Your a is just 0 here. So square root of 2, negative square root of 2. 1 plus square I, 1 minus I. That's your other root. Done. A cubic polynomial has real coefficients. If 3 minus 2i and 5 halves are two roots, what is one additional root? Well, here is an imaginary root. These occur in conjugate pairs. Therefore, 3 plus 2i is also a root. Okay? Now, this is the last thing we're going to do for the day today. What is a third degree polynomial function with rational coefficients so that p of x equals 0 has these two roots? So would you also agree that another root is negative 2i, right?
Could you, well, would that be the same thing as doing square root of negative 4? Is it the same thing? No, it's not the same thing.
It doesn't even matter.
It would be 2i.
It's irrelevant to the problem. A plus bi, a minus bi. The a is 0. So 0 plus 2i, 0 minus 2i. They're conjugate pairs. Now, let's put these roots as binomials, because remember, it's x minus a gives you the root, right? Or the factor. So I have x plus 4. This one will give me x minus 2i. This one will give me x plus 2i. Those are my factors, right? Remember, if a is a root, then x minus a is a factor. All right? So all I did is I took these three roots, because a third degree polynomial is going to have three roots, and I put them in the form x minus a. All we got to do is FOIL all this crap together. Let me tell you, when you have conjugate pairs like you do here, do them first. Okay? So the first thing we want to do is these two. So FOIL these. X times x is x squared. On the outside, plus 2ix. On the inside, minus 2ix. And the last's minus 4i squared, right? Remember that from our unit on quadratics? So these guys cancel. And remember, I squared equals what? Okay. So this is really x squared plus 4, right? So I have x plus 4, x squared plus 4. Fair enough? FOIL that. So x times x squared gives us x to the third. Outers is x times 4 gives us plus 4x. My inners, 4 times x squared gives me plus 4x squared. And my lasts, 4 times 4 gives me plus 16. All you need to do from this point, you have no like terms. Put this in standard form by putting them in descending order. So you've got y equals x to the third plus 4x squared plus 4x plus 16. There it is. That's it.